Hello, this is Mrs. Rodolfi, and I am going to be going through lesson 31.3 practice, which is graphing a 4. So in this lesson, it kind of wrapped up 31.1 and 31.2, where you're using the vertex, and then you are also factoring to find the zeros. So let's go through this together. You're going to need a separate sheet of graph paper. There's really not a lot of space in my notes, so definitely grab some graph paper and let's get started. Y equals x squared plus 5x. Let's first find the vertex. So x equals negative b over 2a. A equals 1 and b equals 5. Negative 5 over 2 times 1, which is negative 5 divided by 2. Negative 2.5. So this is going to be our axis of symmetry. X equals negative 2.5, and the x coordinate value of the vertex. Y equals negative 2.5 squared plus 5 times 2.5. And plug this all into your calculator at once. So just to make sure you use parentheses, negative 2.5, parentheses, x squared, plus 5, parentheses, times 2.5, and that's going to give us 8 something. Hold on, I think I must have done some. Did I do negative? Oh, I was like, something's off there. I didn't put negative 2.5 in there, so let's go back and redo that. See, one little mistake, it's going to mess it up. All right, negative 2.5 squared. Negative 2.5. All right. That is the correct answer, negative 6.25. So that's the y value. Our vertex is at negative 6.25. Then we need to find the zeros, so we need to factor this. So x squared plus 5x, I know I can factor out x. So I would put x on the outside by x, and 5x divided by x is plus 5. So usually when you're missing the c value, if you just have your ax squared plus bx terms, then usually you want to factor out a greatest common factor. Then put them both equal to 0. X equals 0, x plus 5 equals 0. Minus 5 to both sides, x equals negative 5. So our zero and 0, 0. All right, now we can graph these and label everything on the graph. So let me grab my just gonna graph it on the right over here to give myself more space for the other graphs. Count by 2's on the y-axis. -2, -4, -6. And then 1's on the x-axis. All right, so our vertex is at negative 2.5. About right here. And then Zeros are at -5, 0, and 0, 0. Draw my parabola. And then it wants x is here at -2.5, -6.25. It's the vertex. Then we have our zeros over here at 0, 0, and -5, 0 is already written right there, so I'm just going to leave that there. And then let's draw a line for our axis. And our axis of symmetry is x equals -2.5. And pause the video and try number 6 on your own, and then come back to the video and check your work with me. So for plus 2x. So my a value is -1 now. A equals -1. So I know that when a is +1, it's this U-shaped. If it's -1, it's going to be the inverse of that, or a reflection of that. So that kind of gives me b equals 2. Plug it into our axis of symmetry, -b, so -2 over 2 times a, 2 1. So our axis of symmetry is x equals 1. Then let's find the y value so that we can find the vertex. Y equals, so remember to keep that negative on the outside, and then I'm going to use 2 times 1. 1 squared is 1, but we still have to put that -1 on there, plus 2. -1 plus 2 is at 1, 1. Then we need to find our zeros. So we need to find a greatest common factor. Again, I'm noticing I don't have a c value, so let's pull out an x. And is -x, and then 2x divided by x is plus 2. Put these equal to 0. -x plus 2 equals 0, minus 2, -x equals -2. We need to get rid of that -x by dividing by -1. -2 divided by -1 equals 2. So the x-intercepts are at 0. Let's draw the graph now. What did I just do with my black pen? So I know my vertex is at 1, 1, so I don't need to, I'm just going to count by ones. That's where I need to go to. Then I just label every other number just to spread it out so it's not so cramped in. Okay, so now 1, 1, and then my x-intercepts are at 0, 0, and 2, 0. Different color here. All right, and then let's the x-intercepts are at 2, 0, and 0, 0. And then let's draw that axis of symmetry, and our axis of symmetry is at x equals 1. All right, here is your graph for number 6. And then come back over here. All right, so for number 7, x squared plus 1/4, a equals -1, b equals 1/4, -1, 2 equals 1/4 divided by -1. So I'm going to do parentheses, fraction mode, -1 over 4, and then divide 1/4. So our x all right, now use that to find our y value of the vertex. Y equals negative, and then substitute 1/4 squared plus squared. So you're going to square each side of the fraction. 1 squared is 1, 4 squared is 16, so that would be 1/16. We can always convert it though. So 1 divided by 4 squared, and then 1/16 would be 0.0625, and then plus 1. What is going on? Oh, you know what? I am just, this is -2, so hold on, let's go back. That is not correct. Go back here to -1/4, so let me do my fraction mode. Divided by -2. Something is not coming up right on here. Let me go back and backtrack my, and b equals 1/4. This is coming up as 1/8, but some. So -1/4 divided by -2 is the same as negative. The book has something wrong. So that should be -1/8, or positive because it's a negative divided by. So that's 1/8. So x equals 1/8. So, and then I didn't fully write it. I have to do 1/4. Oh no, that was right. Okay. So 1. So again, that would be 1 over 64 because 8 times 8 is 64. So 1 divided by 64 plus 1/4. I'm going to keep this in fraction mode. Fraction mode. 1 over 64. And then plus, and then fraction 1. And if we put that into decimal, so that's about 0.265, let's say 0.2 value. So, and then to go make these all in decimal, 1/8 is our x value, is about 0.12. And our vertex is we need to factor it. So for this one, So if a is -1, we need factors of 1/4. And then we don't have a b value. So it's one of those where it's going to cancel out. So it's going to be a positive and a negative. So times c, which is -1 or -0.25. equals -0.25, and then that would cancel out. 0.5 plus -0.5 is 0. So our factors are x minus 0.5 or x minus 1. Those equal to 0. X minus 0.5 equals 0. X plus 0.5 equals 0. X equals 0.5 and so I'm going to graph it on the back. I'll look and grab another piece. So this is for number 7. Vertex was about 0.12, 0.27. So I'm just going to count by ones since we don't need, that's a very -4, -2, -4, 2, 4. All right, so 0.12, let me grab another. To 7, so barely above. And drawn a smaller graph, they're going to be really close, and then it's at -0.5 and positive 0.5. Zero is one x-intercept, and then 0.50 is the other. And then if we were to draw our axis of symmetry, it would all right. For 8 and 9, try those on your check your work. And then you're going to use those to answer number 10. All right, I'm just going to use the book for 8 and 9 since A equals 1, B equals -3, X equals 3, because if it's -b, this negative 1.5. So x equals 1.5. Then let's find our y value of the vertex. Y equals 1.5 squared minus 3 times 1.5. Parentheses 1.5 squared minus 3 times 1.5 minus 4 is going to be 6. So our vertex is 1.5 negative 6.25. So with this one, A times C, A is 1, C is -4. So factors of -4 that add up to -3. So I already can think in my equals -4 and -4 plus 1 equals -3. Put those both equal to 0. X minus 4 equals 0. X plus 1 equals 0. We would add 4 to both sides. X equals 4 is one of our x-intercepts, and then subtract 1 from both sides. X equals at 4 and -1. Now we can draw the graph and label all of these points. So the same type of graph. -2, -4. All right, so our vertex is at 1.5. So go 1.5 to the right and then -6. So maybe 1.5, -6.25. And then more. This would be -6. And then our x connect my points with my parabola. And then we need our axis of symmetry, which is at x equals 1. All right, number 9, -x² plus 3x plus 4. Notice how similar this is. So the well, let's find out. Let's plug it in. So again, pause the video, try it on your own first. You learn by doing. Come back and check your work. All right, so let's go. A equals -1, B equals 3, x equals -3. Oh, and 3 changed to positive, so we should be getting the same answer, right? Because now the just negative numbers flip. 2 times -1, 1.5. So our axis of symmetry stayed the same. Notice in number 10, describe the similarities and differences between the graphs of functions in 8 and 9. How are these similarities? Symmetry. Therefore, that is going to have, without doing the math again, I'm going to get the same answer for my y value. So y would be same vertex. I'm going to put that here. Same vertex for both graphs. All right. Factors of a times c, so it's still -4 because -1 times 4 is -4, but then they have to add 3x plus 4 times x minus 1. Where up here it was x minus 4 times x plus 1, because 4 plus -1 is 3. Put these equal to 0. X plus 4 equals 0, so x equals -4. X minus 1 equals 0, so x equals 1. So now it's putting my x-intercepts at and 1. All right. Hold on. Now, I am just sure that I did this correctly. You know what? Because I'm noticing my vertex is wrong. thinking straight right now, but so I did something wrong. I assumed my vertex would be the same, but I just realized the equation's not the same. So when I got the same answer for x is 1.5, I should not have assumed that my y value would be the same, because and I, just like you, make mistakes. So I am just modeling that mistakes happen, and sometimes we have to go back and fix our work. So let's go back up here. 1.5 squared plus 3 times 1.5 plus 4. All right, 1.5 squared, let's type this in. Times 1.5 plus 4. Hold on, did I put this all? Oh, negative. Go down. Okay, negative parentheses 1.5 squared plus 3 times 1.5 plus 4. 6.2. Different vertex than number 8. And then I want to go back and make sure. So I'm also not doing these correctly. I'm so sorry. Because it's negative x squared. I can't have positive x on each side of these. So my factors are, those are my factors, but I need it to match the equation when I go back. So I'm going to do the box method, because a is not equal to 1. A is negative 1, so I want to work backwards. Negative x squared here, and then positive 4 here. So looking at these, this times 4, and then negative x times 1, and then 1 times 4 is 4. Okay, so that's where times x plus 1. All right, now set these equal to 0. Negative x plus 4 equals 0. One is 1 x-intercept. And then this one, I'm going to subtract 4 from both sides, but then I have negative x equals negative 4. I have to divide. So this one's negative 1. So they actually have the same x-intercept. So 2, 4, 2, 4, -6, -2, -4. All right. So our vertex is 1.56 point. And then let's label it 1.56.25. Then our x-intercepts are x equals 4 and negative 1. And then this is going to be that upside down U-shaped parabola, because it was negative x squared. And then let's over here, let's go back and label those. And then our axis of symmetry is also still x. So pretty much everything is the same. It's just a reflection of each other if we compare this for number 10. So we have the same equation for our axis of symmetry. We have the same x-intercepts, but our vertex changed. Now our vertex is at 1.56.25, where at 1.5, negative 6.25. So when that A value changed to negative and that B value changed to positive, it reflected. Be careful, always go back and check your work because we all make mistakes, and that was a great example of me making a but it's a great thing to model that we all do it, we all make those mistakes, and we just have to go back and fix it, and sometimes it's frustrating, but right. Have a great rest of your day.